Now that we have successfully designed front end and bound smart contract functions with the HTML using JavaScript, let's test it. First, let's test login functionality. Make sure our server is running at the defined port and head back to the browser. Click on the login button. Now it should ask for the MetaMask wallet connection request. When connected, you will see the connected account address on the navbar. Now let's check the balance of this user by clicking on the get balance button, and as we can see, the user has zero balance in the bank. Now let's test the deposit function. If you have refreshed the page, then log in again and enter the deposit ether amount. Here we are adding input value in V, just like we have tested in Remix ID. So we will deposit 0.01 ether, that means 10 to the power of 16. If you have adjusted the V to ethereum conversion in smart contract, then you can directly put 0.01 ether value here in the input. Otherwise, this can also be adjusted in the app.js deposit function at the place where we are passing deposit input.value as a parameter. Like this, you can multiply the input value with 10 to the power of 18 and then pass the value in the send. This will ultimately adjust the ether value to the V. If you have already adjusted V to ether conversion in the smart contract itself, then you will be ultimately passing 10 to the power of 18 ethers and it will throw an error. Not if you have this much amount in your wallet. So back to the DApp, let's click on deposit and confirm the MetaMask transaction. Let's wait for the transaction to get confirmed on the Robston test network. We have to wait a few seconds as it's a public testnet. You can eliminate this waiting time by using Ganache as a local blockchain instead of any public test networks. For now, it's beyond the scope of this course, but you can learn it in the Ethereum DApp Development Advanced course on the DApp World for free, or you can follow DApp World's YouTube channel. You can see as soon as transaction is confirmed, the amount is deducted from the wallet, and now let's check the balance of the user. Let's refresh the page and log in again. The current address is the same for which we have deposited ether, and let's click on the get balance button. And it shows 0.01 ether in our account. Again, this value can be returned in ether itself by adjusting the V to ether conversion in app.js in case it's not adjusted in smart contract. Let's deposit 0.01 ether again and check if the amount is correctly added in the bank or not. After the transaction is validated, let's click on the get balance button, and now we should get 0.02 ethers. Now let's try to withdraw some ethers from the bank account. As you can see, this address in our wallet currently has 3.68 ethers. Let's withdraw 0.0 ethers, that's 10 to the power of 16V, and click on withdraw button. Confirm the transaction and wait for it to get confirmed. Once confirmed, you can see that the amount is added into the wallet from bank. That means the user should have only 0.01 ether left in the bank, and there it is. So everything is working perfectly fine. Congratulations on building your first Ethereum bank DApp with Solidity, Remix, JavaScript and HTML Bootstrap.